I'm with ABD Technologies, and we want to introduce our top-down fracking technique and the tools involved. But today we want to show you the three main components involved in running a top-down frac. That is the valve, which is mounted on the casing string like a sleeve would be. It's a 3-position valve. It has up closed position, middle open position, down closed position. The tool lying down here is a fracking tool. It's dropped in the hole, untethered, and lands in the valve to activate the valve. It's just a plug with a series of retractable no-goes on it. That's what these two sets of keys are. They don't lock into a groove, they're just no-go shoulders to land on shoulders inside the valve. It lands in the valve, pushes the valve to the open position where the frac job is done, and then after the frac job is finished and the pressure's fallen, there's pressure sensors inside the frac tool that tell it to close the valve, and it moves to the down closed position. And then after you've conducted a pressure test on the casing string above, further falling pressure allows the frac tool to move on out of this valve and on to the next valve in the well. That can be done continuously for as many valves as is desired. There's no limit. There's no electronics in the tool. It's a purely mechanical tool that operates on pressure applied from the surface. So everything that's going on here can be controlled and determined by pressure applied or let off or slowed down at the surface. This is the shifting tool. As we said, as we move on from this valve down to the next one, this will be left in the down closed position. This is the shifting tool that's used to run in the hole, go down through all of the valves and pull back up through. And as it comes back up through each valve, it can either be used to pull to the sleeve to the open position for production, or it can be pull a valve to the full reset position where it started here for a refrac job sometime down the road. After it shifts to that position, the tool automatically releases and moves up to the next valve, shifts it, next, in a continuous form. What's important about this tool, this set of tools, is that because it's all controlled from pressure from the surface, it can be automated very easily. The entire fracking process can be automated by the application of pressure at the surface. The fracking tool itself, again, is untethered from the surface, so its movements are controlled by pressure applied at the surface. So it's completely controlled by the pumps, and that allows full automation of the entire fracking job from top to bottom, start to finish. At the end of the job, this will be left at the bottom. It could be retrieved. This is a fishing neck here, but in most cases, imagine it would be just left at the bottom of the well. Also, what this system also allows is that you can, rather than having to pump your surfactant right after the frac job, you can do the entire job. All the valves will be left in the closed position. After you come back up with the shifting tool, all the valves can be moved to the open position, and then the surfactant can be pumped after the frac job is completed. There'll be no mixing of fluids or any of that. It'll all be fracking, and then it'll all be surfactant treatment before production. What that does is helps you to save a lot of water, because you're not having to pump that load of water down between each, going from surfactant to fracking to surfactant to fracking and so forth. It's all being done in one shot, in one continuous operation, and then followed by the surfactant job. So lots of water saved.
This is the 5.5 inch size frack tool. This is the upper end, and that's the lower end. Some of the features, we have a fishing neck on top. This is used to drop the tool in the hole with your lubricator. It also allows you to go in and retrieve this tool should you ever want to. Going down the OD of the tool, I'll point out some of the other features. These are a filter ring, and that's where pressure is sensed above the tool. These are we call keys, and what they are retractable no-go stops. This tool does not require shaped keys or special grooves in the ID of the casing. It literally goes down and locates a no-go shoulder. Upper keys, lower keys. This is a seal ring, and you can see the metal-to-metal backup ring for the seal and a peak anti-extrusion ring. Two more seals, same configuration. These seal in the nipple while you're fracking. This seal assists in pumping the tool away. These buttons right here are bore sensors. They have to do with a technique of guaranteeing the tool will not leave the valve open by mistake. This is the lower sense port. Again, these are seal ring. They're set up to filter 200 mesh grit. And only water go in, but the tool itself is oil filled top to bottom. Oil fluids do not flow through it or get inside to the working mechanism. The bottom end is shaped very much like a frack valve that you're familiar with. And this is used to provide a restriction to pump the tool down hole. We also have a feature on the bottom that allows you to thread on any displacement device you may need, a swab cup or a closer fitting elastomeric seal to reduce water as you're pumping the tool down the hole. Within this lower chamber are pressure sensing pilots that monitor the above and below pressures to sequence the control of the tool. In response to pressures above and below the packing, pilots in the lower chamber control the fishing neck. Very much like a conventional wireline lock. As it positions down, it will release these keys to retract. This tool is a mechanical automaton. There are other versions within our patents, but this is the fundamental core of the product, our Frack Tool. As will be described in more detail later, the upper seal rings are a pair of rings that have a controlled gap to filter out grit and let a little water in the top of the tool. Again, as will be explained in detail later, the lower sense port, again, is stacked rings with a controlled gap to let water in the bottom to sense pressure on the bottom end of the tool. Ready? Packing is on the OD of the tool. Will be described in detail later. It's a rubber plastic backup with a metal-to-metal anti-extrusion ring. There's one here and two here. A further explanation of how the tool works. You can see this is the internal part. See the fishing neck on the top of the tool. There's a key like that sits on this large diameter. And another key sits on that large diameter. These keys don't lock in a groove. They're abutments for a no-go shoulder. The hydraulic pilots in the bottom tell this fishing neck to move. It moves a first increment to drop this key down. When this key retracts, the tool is free to move down and close the sleeve. When you're through fracking and you've hydro tested the closed sleeve, the second pilot communicates with this fishing neck, allows it to go down. The key retracts across the shoulder, and the tool moves on to the next valve in the well. It's very similar to a conventional wireline lock with two sets of keys, two grooves they drop in, but again, these are no-goes, not locking keys. When the fishing neck is fully down, both keys are retracted into their grooves. As the tool pumps away and goes down to find the next frack valve, the spring in the bottom of the tool lifts the fishing neck back up and re-expands the keys before it contacts the next valve. The tool is ready to go again. Okay, the frack tool on the bottom, as I pointed out earlier, has kind of a bull nose on it. And this is so that it pumps down like a frack ball. However, if you want to restrict and minimize the water used to pump the tool down the hole, there's a thread connection on the bottom where you can adapt, in this instance, a swab cup or other commercially available displacement devices. In this particular video, we're going to be testing using city water pressure, 10 gallons a minute, to displace this tool down the hole. So we're actually installing swab cups.
Go.
Okay, this is the frack tool. It's size 5.5 inches. It's about 3 feet long, 7.5 inches OD. You can see it's nicely beveled, so it'll slide down the open hole. This is the upper end. You can tell because these seats and gates are on the upper end. And what you're looking at right here is a seat and a closed gate valve. There are 6 of these arrayed around the tool. In the current position, it's in the up, closed position, ready to be run in the hole. What you're looking at here is a closed gate and the seat that it seals against. We'll talk in detail about this later, but what you're seeing is a closed gate. When the tool functions, it will open like that, and you'll see a hole here when you're fracking. Okay, these gates, the array of them, are carried on a sliding sleeve. Okay, and that sliding sleeve is retained from moving by what we call a detent ring. It's a continuous beryllium ring. We'll talk about it later and how it controls the position of the gate.
As in the well, the pipe would be run with valves mounted along the pipe, maybe one every joint or so. And then when the well is cemented in and ready to frack, this tool, which is the frack tool, will be installed in the lubricator and dropped into the well, which we're going to simulate by taking this frack tool and installing it in the end of this pipe and pumping it down into that valve. The casing dummy from the other end. Here we have a bowl plug installed so we can hold pressure, fill it up with water, etc. This standpipe is just to allow it to hold the water with no pressure while we're manipulating the valve. So it'll have 0 pressure below it, but the pipe will stay full because we have a standpipe here. It requires it to push it up the pipe and out so that, it's very low pressure, back pressure. So we have casing joints. This is a test ring that we will slide over the ports so that we can look at, simulate fracturing pressure, and watch the pressure build up, and we can bleed it off and watch it close and so forth. But we need a fixture that will cover this and allow us to continue building pressure after the valve opens. and then just more joint pipe above. And in the top here is where we'll install the frack tool like you would in a well. A bull plug in the upper end of the casing dummy, and that's for the purpose of being able to fill water from the bottom to the top. It's all tilted slightly this way so that the air all comes to here. When this valve is open, we'll feed water into the bottom through a water hose, city water hose, and fill it all the way up until the water is coming out here. Then we can shut it off. That'll fill the water. After that, this hose will be isolated, and then the high pressure hose here will be open to the casing, and this is the same as the pressure at the surface or at the wellhead when you're doing the frack job. And this line goes back to Haskell 1 horsepower pump, which is right here, and feeds through this line. So it's got a bleed, a supply, and an isolation valve. This is a isolation valve, supply and bleed for the frack sleeve. Once we've opened the sleeve and begun fracking, we'll slide that sleeve out there over the ports. We'll build up pressure. That pressure will show here and on the strip chart recorder. So we'll be able to see the frack pressure building, and then consequently when we shut the valve, we'll see this pressure bleed off to nothing while the pressure above should hold so that we can do a casing test above before moving on. And this is the strip chart recorder. That's a previous strip chart that's on there. That's roughly what it will look like when we get through. The red line will be the pressure above. The blue line is the pressure, the frack pressure, the pressure in the sleeve. So you can see once the valve opens, they join together, and we'll pump up together just like we were fracking. And then there's a breakdown of the formation, and then at some point we'll bleed off, allow the pressure to fall, slow the pump down, and the pressure will fall to a point that trips the upper pilot and allows the valve to move to the closed position. Once it moves to the closed position, the pressure above will build back up, and the pressure in the sleeve will go down to 0 because it's open to atmosphere, indicating that the valve is closed. Then we'll do a little hold to test the casing. Then we'll bleed down to a lower pressure, at which time the low pilot will trip, and that'll allow the valve to, the frack tool, to move on out of that valve and move on down to the next. So now we see the water purging out the top, and we know the air is finished coming out of the pipe. We'll close this valve off. That'll allow us to continue pressuring up on top, and push the frack tool into the valve, and then pressure on up so that we can open the valve and continue from there.
As you can see, the gates are closed.
So now the pipe is full of water. Shut off the bleed valve that was purging the air out of it. Now I'm going to feed water into the top of it through this hose, open the standpipe down there, and that'll allow the swab cups on the bottom of the frack tool to pull the frack tool into the valve. And you can see an indication that it's landed by the fact that the water stops coming out the standpipe because the frack tool has landed and it's plugged the hole, plugged the casing. We're going to turn the water on now. Got the standpipe open down there, so it's pushing the frack tool down into place. So it's displacing water out of the end of the pipe because it's going into the pipe, and the swab cups are pulling the frack tool down. And that'll continue until it reaches the valve and lands. Pressure building up. The sound of the pump, Haskell pump, air over water pump. The pressure above, transducer reading the pressure above the frack tool. This is pressure in the sleeve, which is essentially zero right now, and the pressure below, which is essentially zero, but the height of that steam pipe out there generates this 2 psi. So that's why it reads 2 psi. Are you ready? Okay, we're going to build up pressure when it reaches about 200 psi. The sleeve will open, and then the water pressure that we're building up will come out the ports, and then the pressure will bleed down to zero. Then we'll slide the sleeve over, but momentarily you'll see the sleeve open. We'll check to see that it's wide open, and you'll see the water come out when it opens. It's getting close. It's probably up to about 210 now. Trying to move that sleeve down against the load of the decant ring. And as soon as it reaches that equivalent load, it'll slide down to the open position. There we go. We'll walk down here. And you can see that the ports are in the full open position. So now we can continue to pump, and this is what would be the fracking fluid. Now that the valve is open, we'll slide the sleeve over the ports. And that way it'll allow the pressure to build up, and we can continue up and simulate our frac job. Pump now. You can see the valve opened here, and it joins with the sleeve pressure now that I've slid it over. And so the blue line and the red line are together because the valve is open. And they'll continue to build pressure. And we're going to go up to say 2,000 psi here and simulate a little frac by bleeding off, and then do the breakdown of the formation, and then go on down to where the valve will automatically close. Pressure above, which is the red line on the strip chart, the same as the frac pressure and the pressure in the sleeve out there, which is the blue line on the strip chart, are both together right now because the valve is in the open position. So they'll stay together until such time as we close the valve. Stating what the strip chart would look like, you know, if you pumped up and waited for the formation to break down step by step. So it's a faux formation frac job. Okay, we've got the pressure built up to almost 2,000 now. The pump regulator is going to set that pressure so it's flowing down. To simulate the frac on there, we've got a valve, a needle valve, metering valve on that sleeve out there. I'm going to go open it, and that's going to let some water out of there, and that'll look like, you know, a formation breakdown on the strip chart. So it'll lose some pressure. The pump will speed up a little bit, but the pressure will be falling. So that's what I'm going to do now. Just varying the meter valve here so that this strip chart gets a little wavy, lets pressure fluctuate a little bit more like it would look in real life on a frac job. Every time the valve moves, the frac tool moves the valve, moves the valve, you see a little squirt of water come out the top of the standpipe, and that's from displacing the water. The frac tool moving down, so you get a little, regardless of all the other splash you might have seen before, there's also a little twerk of water coming out the bottom there. And we'll see it again here when we close. We're going to close the valve by letting the pressure fall to around 1,000 psi. Fall to that here when the pressure gets down to about 1,000 psi. they'll both go down. The red will go down stop because the valve is closed. The blue will go on down. So this is the sleeve pressure. And then since the valve is closed, the red and the blue will become isolated from each other. The blue is allowed to fall to zero because it's bleeding off out there. And the red is above the valve. So that pressure will build up. Testing the casing above after the closing. Slide the test sleeve off of it so that we can see the ports again. And you see the all the gates covering the holes. They're in the down closed position. After the test, after the frac job and the valve is closed, we tested the casing above the valve we just fracked through. And to allow the valve, the frac tool to move on, you need to bleed off at the surface. And we'll bleed this pressure back down to just under 500 psi or so in this case. The low pilot is set around 480, 490 psi, and then it'll allow the fishing neck to shift that second time, unsupport that set of keys, and move on to the next valve. Okay, we're down to about 550 psi. We're bleeding down. We're not bleeding down the formation at all. Since the valve is closed, we're only bleeding down the pipe from that valve to back to the surface. When the pressure falls just below 500 psi, it'll allow the frac tool to shift down and leave the valve that it's in and go down and land in the next valve. See. Okay, just looking at the strip chart here after the test is done, I'm going to turn off the recorder. We can see that the pressure here when the valve opened was 219.6 psi. And then this is just filling in between. These are the accumulators pressuring up. We pressured all the way up to, 16, 17, 1800. This maximum here is 2093. And we bled off and we're simulating a frac job. And we slowed the pump down, kept bleeding off. And when we reached 982.8 psi, the valve closed. And when it slammed closed, pressure in the frac sleeve went all the way down to zero. And then since the pump was still running, the red pressure, which is pressure above, continued to build up. I cut it off and it was holding at about 1,005 psi steady. It was a good pressure test. And then I started bleeding down at the surface to allow the frac tool to move on, and at about 452 psi, it looks like 452, 54 psi, the frac tool moved on. So now you saw that I pumped some water in the top and it's coming out the bottom steady. That means the frac tool is out of the valve and is moving down the pipe. I'm going to go and remove the bull plug off the bottom so that I can continue to push the frac tool out and it'll come out the end of the pipe. Then we can remove it from the end of the pipe and it's ready to run through this process again without any redress or attention whatsoever. Just city water being pumped in the top, and then the swab cups come out the bottom. The first one, water in between the two, and the second one covering. Can I just show you? Okay, so you can see that the keys have reset. And it's ready to, the fishing neck is back up, and it's ready to land in the next valve, ready to go again. And that process will be repeated as many times as desired. I'm going to run this shifting tool down into this frac valve and pull it back up. And this notch on the shifting tool will grab the sleeve inside the frac valve and shift it in the up position. Now we have two sets of fingers that go in here. One set is for just opening the valve, and another set, which is the set I have here, is for pulling the valve to the fully reset position, which is the up close position. But as I pull it open, you'll be able to see the gate move up, come to the open position, and move on past and go to the up close position. Okay, this is the shifting tool we're going to use to shift the valve back to the open position and then the up close position, which is a position for refracking. This is the finger that grabs the sleeve. So we're going to go in, it'll locate the sleeve, we'll go below the valve, we'll pull up, and it'll grab the sleeve, and then we'll crank on the screw. This is just a long all thread rod we have connected to it. We'll run it in there to grab the sleeve and then pull it back to the reset for refracking position. And again, this would be run normally on a tractor and a stroker tool. We'll run it all the way in, go through the valve and come back up and grab it. Okay. So I've run in, past the tool, and pulled back up, and it's hitting on the sleeve. Now I'm going to drag it, the sleeve on up.
This will be done by a tractor.
Yeah, this would normally be done by a stroker, tractor, and the shifting tool that you saw. So we'll rotate on this, pull the screw up, and shift the sleeve first to the open position, then we'll move on to the full reset for refracking, which is up close completely. Can see the gate clearly. I'm gonna go, I've got the solid rod, about 4 feet of all thread rod, and just the plate on the end. I'm gonna twist on it and we'll see what it looks like. So the shifting tool has shifted the valve back to the reset position, so it's ready for a refrac job. Now I'm going to pull the shifting tool out, released automatically, and pull it all the way back to the surface. And the job is done.